Hi, it's Gadget UK here again. This time we're looking at an OSSC, Open Source Scan Converter. So it's a HDMI upscaler. You know, you can feed in component, SCAR, RGB, potentially composite. I don't think it does composite, but maybe it does. And I think we've got VGA by the looks of things there, maybe. And a power in, power switch, it says there off on. It says the polarity and connectivity for the the DC jack there. It's sent to positive 5 volts DC. It's got a little non-backlit LCD there. You can probably swap that out for a backlit one. That would be quite a cool mod for this. It's got a couple of buttons here, JTAG connection, I know that because this is JTAG there, A3 in, whatever that is, audio maybe, so you can mix your audio with your video, coming out the HDMI there. AV1 out. AV1 out, what does that mean? Yeah, this is AV1 out / AV2 in. So that can be an input or an output by the looks of things. Maybe it's one of those 4-pin 3.5mm connectors, and that might be the same because that's the same 3 in. So you can have a few different inputs into it, 3 or 4 different inputs by the looks of things. Anyway, I think the first thing I'm going to do, we know the polarity here. I'm going to use the power supply from the Mister here. Same as my the one I use on the MSX, actually the TF MSX. 5 volts, centre positive. Hang on, let's just check that. It is centre positive, isn't it? Yeah, it is. Centre positive. We'll connect HDMI up here. Let's see if we get anything on the TV. It may be a power problem. And plug it in. Make sure, is it on or off? It's off now. Switch it on. Off. Right. Right, we're on the right channel here, and the power supply is on. I'm just looking to see if there's any indicators on this. Switch it on. Nothing. Switch it off. Nothing. So it's not doing anything at all. And I can perhaps show you that from the front. We'll just disconnect the HDMI here. If I just stretch that way around, just so you can see the LCD on the front, and I'll switch it on. Nothing. So we've got some sort of power issue, haven't we? Now I know from experience, from seeing a few channels that support me actually, Philip Bryden was one of them, and one of the guys in my Discord, that these have a number of different power rails, and they have fuses, regulators, and those are the sorts of things that fail. So you know what, the fact we've got no power, that's a good sign, isn't it? Yeah, it may be a bad sign, it may be there's something that's completely short. Let's just get the wrist strap on. Let's have a look inside this and see if we can work out the source of the power issue here. Yeah, it's one of the things with this. This is reminiscent of the Mister, the D10, in terms of the stacked approach here of all these different levels of standoffs, look, and things at different layers. Oh, so it's quite nice with the heat sinks and things here. And crystal sort of hanging out at an angle. It's very dusty though. Look at the dust and fluff in there. There's jasper fur inside this. Yeah, if you don't wear jasper as Jamie's cat. It's still got the protector on that, look. It's still got the protector on the front. You can peel that off. Anyway, let's just leave that in place for the moment. So just having a quick inspection to see if we can see anything that looks burned or charred or anything like that. And no, there's very little on this. There's very little on it. I'm guessing there may be caps and resistors and things on the underside, but certainly from the top side here you've got these 3 main chips, and whilst it looks very dusty, I don't see any signs of damage anywhere. Anyway, we've got the power coming in here, and we've got a little regulator there. That's what that little 3-pin device with a tab is going to be there. So let's just see, do we actually have voltage making it out of that regulator? Multimeter in, volts DC. We'll test from the HDMI here. It's going to be grounded, I think. And let's just test on that tab there. Nothing. Carefully test each of these, hang on, pins here. Nothing. Switch it on again, because I think that was off. Let's just to the tab. Nothing. 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 That's a bit worrying. Let's try from a different point. Let's try. Let's just test from there to the centre point on that. Right, we've got 5 volts coming in. So I'm testing from the shield there to the centre point coming in here. And we've got 5.19 volts. So we know the voltage is getting in. It's going to be a fuse, isn't it? Yeah, nothing getting to the regulator. It's got to be a fuse. This is going to be the world's simplest fix, isn't it? I wonder if it's on the underside here. I think we need to take this out completely. I'm going to need to undo the screws on the bottom here, because we need to look on the underside. There may be a fuse on the underside. And at least then we can also check the path from the connector, you know, the DC thing there. Hang on. Oh god, I'm going to be really fiddly putting this together. I mean, you could probably do it easily with some pliers, you know, like I'm going to need to use pliers, look, to get... Oh, hang on. I'll tell you what, let's just take the standoffs, because the standoffs are the thing that hold it in. Yeah, so Jamie technically donated this, he says I can have it, but if I can get this working, I'll offer it back to him as a spare, or offer him something in the way of payment for it, because you know what, I was going to buy an OSSC at some point, and then at least Jamie doesn't lose out. Jamie's just, you know, it's a small channel, and obviously he's trying to build his channel up. He lives on his own, and anybody who knows about the cost of housing and rent in the UK knows that it's incredibly difficult, certainly if you're living on your own. You've got 2 of you in a household, it's a bit different. It's still hard, don't get me wrong, it's incredibly hard. Yeah, so looking on the underside here, there's a fuse. There's a fuse there, can you see that? Well, F component. Let's just test, I bet that's it. I bet that's the issue. Now, the reason it could have blown, well, it could be a fault. But it could also just be, well, I mean, look how dirty it is under there. It could just be a bad connection. Sometimes you get a bad connection or a power connector, and it arcs a little bit, you know, it wobbles on in and out, you know, you knock it a little bit, and the current, you get little spikes in current, and the fuse blows. It's really that simple. And sometimes, and Dave Jones did a video on this recently, EEV blog, fuses are subject to temperature changes. Different fuses can be really negatively affected in terms of their characteristics based on, there you go, it's open circuit. Yeah, based on temperature. Yeah, that fuse is blown. That is the issue. I mean, it's tiny, it's no wonder that's blown. I mean, just look at the size. I can't even see it from this distance. It's the 3 components here. You've got like a cap, a diode, I think, and then the fuse. The fuse is on the top of my thumbnail there. Can you see it? I can't see it from here. It's so small. It's tiny. It's absolutely tiny, that fuse. No wonder that blew. I mean, the size of it is not why it's blown, but the point is, when you get really tiny things like that, you get a limit in terms of what current that could actually handle. I bet that's borderline in terms of being a possible for a failure in general on these, which is why, you know, I've come across a few people, including the guy in Discord, name up there, his was just a fuse. I bet that's what it is. I bet there's nothing else wrong with it. So I'm going to throw caution to the wind. I'm going to remove that, and I'm just going to bridge over it with a blob of solder, and then I'll try and find something the right size. Going back to Dave Jones again, EEV blog. This is where the EEV blog ruler comes in, because it's got the little SMD, I can't find where they are now, the SMD footprints somewhere on it. Yeah, and they're here. So if I line that up next to the fuse, or even put the fuse on it, I'll be able to work it out. I think it's an 0603 actually. Yeah, it could be a 0805 actually. It's either 0805 or 0603. Anyway, let's just try and get this off. You know, this is one of the things I love about electronics, is that you find that, you know, it's Occam's razor stuff. Most of the faults you find generally in systems are the simplest ones. You know, this is the simplest kind of, you know, a genuine real world fault. You know, it's caused Jamie a huge problem here, and he's had to spend money. But the bottom line is, he may now have a spare if he wants it. And so let's get some solder. And it's a simple thing. It's pennies, potentially. I mean, these are famous last words, so after we do this, probably find it doesn't work, and the board sets on fire or something. I don't think so. I think it's going to be just this fuse. I mean, I can measure on the regulator in a second before we actually power it on. There we go. It's off, look. Yeah, it looks a mess. We can clean it up in a minute. So let's just try and... Hang on. It's stuck down flux now. Look. Yeah, get that off there. I can put that onto that ruler in a minute. Just move out of the way so I don't lose the flipping thing. Anyway, let's just now have a measure around here. I'm just going to measure between the 5 volts. I can find the connector. Where's the connector gone? No, it's this one here. It's these connections here. Let's just measure these. Yeah, those are the grounds, those two. Yeah, so there's no resistance there because the fuse is not there. But if we flip it over and measure on the regulator here, let's just make sure we don't have any shorts here. So I should measure all 3 ways here. Oh, we've got a short there. So we've got a fault. I think, unless I'm touching that can of that. No, I've got a short there. That's interesting. Maybe that regulator's failed. But it could be one of the caps. This is the other possibility here, like maybe one of these caps is shorted. So it's not just a fuse. Yeah, we've got a short there. We don't have a short there. So my recollection, and I could be wrong, is this like an AMS 1117, but it might not be. It says 3.3 there. Yeah, there's 2 different types of pinouts for this style of regulator here. So I am assuming, and we can test that because we've got the, I can get the meter in. The centre point here is the 5 volts coming in. Does it go there, or does it go there? Hang on, get onto the flipping thing. Oh, the fuse isn't in place now, is it? Right, let's just bridge that thing, because you know what? Until we've got a path there, we're not going to be able to easily work out what's going on. So I am just going to bridge that with some solder. If I can. It is a big gap, but, well... add it then. There we go. So we're just going to bridge that. Using a tiny bit of fine wire would be a better idea. Let's just test that diode, because you know what? It could be reverse polarity's failed or something. Yeah, I'm getting a diode reading there. Yeah, there's not a short there. So that diode for reverse polarity protection. Yeah, solder points don't look great, do they? It's like a silhouette on the top of there, but it could just be the lighting. Probably it's just the lighting. Right, flip it back over. Now we should have a connection, if I can get the meter in, from the centre point here to one of these, maybe there. Nope, maybe there. Nope, there. Hey? I'm not following how the power is not going straight into that thing. It goes through the switch. Maybe the switch wasn't on. But then if the switch wasn't on, why are we getting a resistance? Yeah, not enough hands. Right, let me show you 330. Switch it off. Oh, now it's on. Maybe the switch shorts out the power. Like when it's in the off position, it drains it. Now it's on. Right, let's just test if we've got a short here. Now we go. Yeah, we still have a short there. So the 5 volts is short to there. Now, if that's the tab, that's the 3.3. That means the 5 volts is shorted across to the 3.3. I think, assuming that this regulator has got 3.3 there, might not. That might be 3.3 here. And actually, I'm inclined to think that is the case. Look. Yeah. That's the ground. So, the 5 volts and ground, I think, are shorted out. We can test if that's the ground by, I don't know, testing to the, you can't see the VGA connector. Yeah, we've got a dead short there, 0, 0, 0. But if we measure to that pin, the 5 volts coming in, is 002. That tells me that this is ground, that's 3.3, so let's just test from 5 volts 3.3, no short. From ground to 3.3, no short. Our short is between 5 volts and ground, yeah? So it could be this cap here, and it could just be this regulator. Don't know. That's what I'm thinking, because, well, yeah, it's the most logical thing. I think we should start, perhaps, I was going to say by getting off that regulator, but look what's right next to it, the screen. That's not going to like having hot air on it, is it? Maybe we should just zoom in a little bit and have a look at that cap there, just in case there's any clues, visual clues, like the cap cracked or something, but I bet it's alright. I bet it's not the cap. We can have a look at that regulator as well. I see a little line there that, yeah, well, it's just kind of piqued my interest as it's that damage. Anyway, let's get a cotton bud down here just to have a bit of a clean on that. I don't know, I'm not really seeing any clues. You can see a little mark there, it's just where it's been scratched, I think. I don't think there's anything wrong with that. That looks fine. And of course, looking fine and being fine are two totally different things. Maybe we should get this regulator off. The other thing we don't know is we don't know where else the 5 volt goes. So in other words, the 5 volts could go somewhere else on this board, not just to this regulator, but somewhere else on the board, and that could be short. I mean, it could be this screen. The screen, for all we know, is a 5 volt LCD. I doubt so. Back of it is marked New Haven display. I could look up that part number. Right, I'm going to get that off with some low melt solder. Just because the video, display there, the little LCD screen, is right next to the thing. Yeah, I could remove it. I don't want to have to desolder loads and loads of things here. And the screen, you can argue, it looks a bit fragile. I could imagine heating and reheating the points on that, the interconnect for it, may cause a problem. So I'm going to reuse some little pellets of low melt solder here. I've got some on the table. And yeah, we'll just see if we can get it off. Yeah, very challenging to get in this space down here. Tweezers might be a thing. Let's just lob that like that, and just try. Oh my god! I'll tell you what. Let's get the tweezers and just not try and get it everywhere. Let's try and get a little bit here. There we go. That's what I was trying to aim for. And a bit down here. We can put that last bit down there if we can get it down there. Yeah, right next to that screen here. So let's just give that some time. You can see the heat passing through to this point over here. Ah, it's moving around, look. There we go. It didn't take long, did it? Obviously, because if you heat, hang on, try and get the tweezers right on the side of it here. If you heat the tab, obviously the whole thing heats up like that. There we go. It came off really easy. Has one of the legs come off there? What's that? No, it hasn't. It's just the solder. So we've got the regulator off. Right, let's just test if we still got a short. No, we still have a short. So it could be this cap. Let's get that off next. So it's just removing the solder from the tip. We don't have any low melts on that at the moment. Let's just see if we can get this off. Oh my god, there's so little space to see what I'm doing here. There we go. Let's now see if the short's gone. It could be quite difficult to diagnose this, because you know what, if this hasn't resolved it, there's still a short on the 5 volt side somewhere, and it's follow where the 5 volt side goes. Hang on, it's here, wasn't it? Still got a short. This is on the 5 volt rail, isn't it? But why would a crystal short? That would be really weird. I think I need to go try and find some schematics for the device, because Well, it might just help. I might be able to understand where the 5 volts goes. It could cut to one of these customs. One of these customs could have fried. You know, we could be barking up the wrong tree here, thinking it's the regulation and stuff and decoupling. It might not be. It could be something else, like a little buff chip or something, or one of these main custom chips. Wow, those look a bit shocking, don't they? HDMI connections, filters there, look. Anyway, I'll report back in a minute when I've gone and found some schematics, I think. Before I go and get schematics, I'm just going to try and mop up these bits of low melt solder. There's no space. Yeah, trying to get that braid like that there. Oh my god. I think it's a case of the best way would be to cut a piece off the right size and then use tweezers. I can get the toothbrush on it in a bit and have a wider clean up. I mean, there's loads of flux from manufacture. Look, it's pretty shocking, this board. You know, made to a price point, really. Probably from AliExpress, I would think. It is marked as made in China. So, yeah, it's probably from eBay or AliExpress. Yeah, put it on ohms, just to tell you the ohms reading here. And this might be legit. You know, it's like 3.2 ohms. Maybe it's supposed to be 3.2 ohms, but I find that hard to believe. You see, if we flip this over and measure on the crystal here, yeah, the points on the crystal are here. It could be the crystal short. That's a possibility. That looks like the ground. That's not the clock. Yeah, there's not a short there. So you know what? The crystal is kind of ruled out. It must be on the 3.3 volt rail, that crystal. I don't know what that is. Jasper hair again. You see, I'm thinking there could be something, a transistor or something that passes the sync through here. Maybe it's on the 5 volt rail, so something like that could have shorted out. It could be something to do with the C-sync or sync somewhere, a buffer of some sort. Now at this point here I really should have gone and got the schematics. I'll show you those shortly, but what I decided to do was refit that little regulator and capacitor. You can see me fitting those things here, and then power the OSSC using the bench power supply from Ian Scott Johnston, and just current limit it, so you know there would be less risk just limiting it, so that as we power this, if there is a short, which we know there is, there's still a short, we can then maybe feel around, feel if anything gets warm, what's actually absorbing the power there, maybe just gradually increase the current until I can feel something getting warm. Now if I'd looked at the schematics, you'll see there are a number of regulators on the other side of the board, and that's where we'll lead to in a minute. Don't like the shape of that solder. I'll do. Yeah, all the time I've been soldering around here, we are melting off the print on that screen. That screen may no longer work at the end of it. Right, so I've got the Agilent bench power supply set to 5 volts, half an amp. I'm just going to connect the centre positive here. There we go. Make sure they're not shorting. So we've got 5 volts centre positive going in there. Yeah, and you can just about see the bench power supply. If I put display on, hang on, what's it on display? Yeah, 5 volts, half an amp. And I'm going to switch it on. Drop to 1.8 volts. And if you look at the display there, switching it on, hang on. It's on. Nothing. No LEDs, no nothing. And yeah, with half an amp, yeah, you're not going to get much. Yeah, so this is the point where it could take me some time now to work out what the issue actually is. Yeah, so the current is still set a bit low. I've got some freezer spray here. I think this chip here actually We're going to need to remove that heatsink and work out what that is. I think it's that chip. Right, I'm just going to just spray around this area here. Freezer spray, hang on. And then there. Switch it on. See that heatsink? Right, just watch the heatsink. You got like a bit of frost on it. See here? It's not really revealing much actually. If I just feel the tops, yeah, it's still cold. It's drawing 1.2 amps. I'm going to switch it up to 2 amps. It's a bit risky, but well, I'm going to get nowhere at this rate, so right, 2 amps. The thing is, I'm playing on the side of caution here, you know, in terms of I'm not feeling anything getting hot. This is the mystery with it. Oh, I can't turn it over now because of the HDMI lead. Right, we're getting nothing out on the HDMI anyway, so I feel some warmth here. I do feel some warmth here, just under here. Maybe it is the chip that's over there. It's not one of the small things though. Ah, there's our shot. Just a minute or so testing at 2.2 amps, I could smell something. I sprayed around with freezer spray, couldn't work it out on the top side. And I told you before there was some heat around here. There we go. Can you see that? It's allowed that to cook itself. Now that may have killed something entirely. We may now have a problem that's not resolvable. But I need to go work out what U6 is. It's not easy because it's such a small component, and obviously it's a bit melted on the top of it now. So let's just zoom in on that. I don't know, what is that? I think we've got no chance of getting the part number off that. It's like it says 0 something on it. Anyway, U6. Yeah, my guess is that's a VREG. I'm sure we're going to see a short to the 5-volt connection. Let me just measure that. But you see, if we'd not gone this approach, we could have spent considerable time removing everything on the 5-volt rail here. Alright, it might not took that long, and it might have just been a bunch of regulators. You know what? That isn't on the 5-volt rail. It's not on at the moment though, is it? Hang on, switch it on, I think. Yeah, if you're testing, you need to have it on. Yeah, that measures 002, but I think that's a ground. Ah, there's the 5-volt connection. So, yeah, I think certainly this is one part of the problem. It may have killed whatever's connected to it, though. Because let's say that was a 1.8-volt regulator, and we've just fed 2.5 amps into it to try and blow it up, as we've done here. Anyway, I'm going to go look at the schematics, see if I can work out what U6 is. Yeah, if the silk screen matches the schematics, and I've no reason to believe it shouldn't, it's a 3.3-volt regulator. Now, I was looking at these. I'll put the part number top left from the schematics and show you that page of the schematics. Yeah, on eBay I found a seller that seems to be in the UK, you know, like almost next day delivery. It's like £10 for 3. And then I thought, well, why don't we just try and bodge one of these on, an AMS 1117. It could be a bit tight trying to fit it in there. I'm sure I can do it, join it up to one side or other to this cap here on one connection, and then a couple of wires. And this one's got 4 pins because it has an enable, and I was looking, oh, hang on a minute, this hasn't got that. This is just like voltage in, voltage out, ground. That one's got an enable. Well, the enable just gets joined to the voltage in, so that in other words, when the 5 volts is passed in, it enables the regulator anyway. Is that one of the problems with this design? It's the size of the thing as well. Rated up to 200 milliamp. It's tiny, this thing, isn't it? It's no wonder these have power problems, these OSSCs, and it's nearly always power problems. You know, the problems with the OSSC when they fail seems to be predominantly to do with power. And well, it's no surprise, really. I'm zoomed in really close here. I should pull the magnification back a bit, shouldn't I? So I'm going to try and just bodge this off, I think. In fact, let's not do that. Let's use some hot air. Go into my magic temperature of 405 degrees communist, as Chris Edwards says. And let's just try and heat this little thing. I wish mine wasn't shaking so much. There we go. Go on. The other reason I don't want to spend the £10 on the regulators, well, I think £10 for 3 regulators is a bit overpriced, to be honest. There's a hair there. And there's just this question of, is something else dead? If something else is dead, 1 or 2 of the things on the 3.3 volt rail, you know, we could be wasting our time here and money. So, yeah, I think I'd rather just bodge a regulator on and see if it works. And if it does work, I wouldn't even then replace it. I'd just leave whatever I've bodged on, because you know what, I think one of these regulators I'm choosing here is going to be better than the one that was there. I could be wrong, but I'll bet they're not dissimilar in terms of the 200 milliamp rating. I mean, it's huge, isn't it? But you see, this is obviously going to handle current a hell of a lot better than that piddle little thing would, regardless of whether it's rated for the same temperature or not. So I'm going to go look at the pinout now and work out where best to join it. But one of these connections here is going to be the 3.3, one of them is going to be ground. So somewhere here I might be able to join one of the legs up and then just have a couple of wires to the other points. We don't need 4 points on here. As I said, the enable was just going to the 5 volts anyway. Right, and I guess we can test that as well. If I measure on beep test again, 2 of these pads here should be the same. Now the one on the right there was the 5 volts, if memory serves. It's just a question of, does it go to one of these others? That's a dead short. Not there, yeah. And we need to see if the short has gone, don't we? So if we measure on the power connections down here, these are the power connections. Short's gone now, I think. We can flip it over. Yeah, the short's gone now. We've got a low resistance, but not like we had before. It's like showing 0.38, 0.138 it's shown on the meter. So that has resolved the short. Let's just check it on that cap, because you know what, I'm not convinced. Yeah, that's right, the short's gone. Yeah, so I am going to just bodge it on the underside here. So it goes ground, output, input. That's 5 volts, that's ground. So I can just try and add a bit of solder here like this, and just try and bodge it onto the side of this cap. And that's, well, it will be if it goes in place, 1 of the points done. Let's just try and smush it this way slightly. There we go. So that's 5 volts in, just need the ground and the 3.3. And of course the reason that regulator shorted could be short somewhere else on the 3.3 volt side. I think we'll measure that just before I solder this here. Right, so our regulator's on there, it's bodged on there. Let's now connect up power. Let's just put the power supply back on. Right, I've set the Agilent to 1.5 amps this time, not 2 amps. And I can try and measure that. If I can find a ground somewhere where I can just wedge my ground. I'm just going to set the display so I can see what it's consuming. Yeah, switch it on. Switch it off. Oh, and it's on. We've got text there. It's drawing a solid 1.17 amps. I'm watching it. Seems alright. Maybe it's just that regulator. And I currently limited it to 1.2 amps. It's not drawing any more than about 1.115 amps. So, and it's fairly solid. It's fairly stable. 5 volts is 5 volts. It's on. Looks okay. Switch it off. So yeah, I'm corrected there. That's backlit. I didn't think it was backlit. That's quite nice, isn't it? Right, so let's just clean up with the mucky mess we've made here. And we may have secondary faults yet, I don't know. Just because the screen's on and it says OSSC doesn't mean it works, doesn't mean something else is not baking on the other side, even though it's not drawing more than 1.1 amps. It doesn't mean there's no second problem here. There could be. And the other thing to take into account with something like that is it might not be the regulator that's caused the secondary problem. It could be that whatever failed killed the regulator because it was pretty much shorting, and the regulator that's on there now is a bit more beefy, so it handles the shorting. If you see what I mean, not really shorting, but 30 ohms. Something is 30 ohms maybe when it shouldn't be 30 ohms. And that's what killed the original regulator, so, you know, yeah, I'm not convinced until I see it absolutely working, but you can see how much better that's coming out now. Right, so rotating you around so you can see it. If I switch it on, OSSC, firmware, 2014, 2019, nothing on the display. Is that normal? Let's try and press a button. Yes, this is where you select your inputs. Now this is the thing, maybe one of these inputs is faulty. Because we don't get anything on the screen there. So I need to go find an RGB source, I think. Let's switch that off. Just feeling the tops of those things. Stone cold. Doesn't mean everything's stone cold, but anyway, stone cold. Right, so I've got the TF MSX on with a risky MSX card. There'll be a video coming up on that very soon. And switch power on. Yeah, it says no sync. What is that connector there on the back? It's like, that's what I'm not sure about. Like, which one's AV1, which one's AV... I don't even know where the lid's gone now. There were 3 parts to that, it's there. I just hope I don't kill my TF MSX. AV1. In. Right, so that is AV1. Let's just try it and choose AV1. AV1 RGBS, no sync. No sync. Well, it's going to be 2 repairs. Guess who just broke the screen? I literally was trying to undo that and I just leant this way gently with my thumb. I heard crack. Straight away, cracked the screen, so I need a new screen as well. Oh, joy. I measured the other regulators on the underside and I see voltages like 1.2 volts, 1.8 volt, 1.8 volt, 2.5 volts, 1.8 volts, etc. on the same sort of style as the one we replaced. The one we fitted was slightly different. Just putting some IPA here. I'm removing this heatsink. I've ordered a chip, I don't even know whether this is the one, that connects, you can saw there was a bit of pressure on that, that's how that breaks. You just need a slight bit of pressure like it, and it cracks. Anyway, £15 cheapest I could get one of those for. I mean, if I'd gone to RS or DigiKey or Mouse, I might have got one for, I don't know, £4 or £5, £3 or less, I don't know. Anyway, we've got the heatsink off there. Yeah, I ordered the chip based on the schematics. So is this the one I've ordered? I don't know. But I ordered the one, yeah, it's this one. I ordered the one that connects to the 3.3 volt rail out of that regulator. It was the 7002 chip. Yeah, TVP 7002. So I'm assuming it's that. Might not be. We're just guessing here. We're guessing based on probability that the regulator that powers this is the one that was shorted. But is something else the reason why this chip is maybe dead? I don't know. So it's going to take a while for the new chips to arrive, and it's going to take a while for the new screens to arrive. Is it worth it? I don't know. It's like, I think the chip was like 15-20 quid shipped. By the time you got to like 20 quid for the screen, 20 quid for the chip, you spent £40 on it. You're getting towards the cost of buying a new one. I mean, alright, they're more than that, maybe 3 or 4 times more than that. It just seems logical to me that if a regulator's died, you should try and trace what that provides power to, and it provides power to this. It's seemingly nothing else, this. These other regulators are going to be for other things, you know, you've got some here, some here. Those are going to be things powering these things. And I think the reason they've done that is to isolate power, you know, one chip from another. You know, if each one's on its own power rail, you get cleaner video and cleaner audio. It's got its own little regulation circuit there. The Texas Instruments parts, those original regulators, by the way. And these are Texas Instruments parts as well. So the video is running on in length a little bit, and there's got a lot more footage. So there will be another part. I'm going to try and squeeze it all into the next part. It's going to be a packed next part. Yeah, if it wasn't bad enough that I damaged that screen, we've obviously got a secondary fault. Traced it, just looking at the voltage of that regulator, you know, what does that provide power to? The 7002 chip. So we've got one of those coming. We've got a new screen coming, but there'll be more faults yet. There's another fault. Besides me breaking the screen, you know, there's a fault that actually translated from the, you know, the original series of events that caused the fault, or the faults, because we've got plural. We've had a fuse, we've had a regulator, we've had a 7002 chip, as you'll see in the next video, but there's another fault beyond that. Then there's another fault occurs as a result of scoping it. Just scoping a pin kills something on there. You'll see that in the next video. It doesn't really kill it. I find a fix to it, but it just causes a problem. You can see some clips of that as I've been talking there. We also have to flash the latest firmware to it. There's some other stuff to do with the firmware and the FPGA on there in the next part as well. And we upgrade it, obviously. But anyway, there's a lot packed into the next part. So if you thought this part was a little bit boring, do check out the next part, because there's a lot more. You may learn a little bit about these. I actually learned a lot about these because we had so many different issues. So a huge thanks to Jamie Morgan. Please check out Jamie's channel down below. And if it wasn't already clear, and I'll talk more about him in the next video, Philip Bryden helped with this because he'd done some repairs previously on one of these. My faults were a lot more extensive than his and a bit different to his, but he did provide, as you see in the next part, one of the chips. So a huge thanks, Philip, for sending me that chip. So please check out the links down below to Philip's channel and Jamie Morgan's channel. If you like the video, please give it a like and a share. If you'd like to support the channel, please see the Coffee and Patreon links down below. I'll catch you in the next video.